My name is Vahanda Vudyan. I'm a physics experimentalist for 30 years, and I have always replicated laws of physics, especially the experiment. And today I am comparing the aircraft aerodynamics compared with the birds, geese, by Vahanda Vudyan, physics experimentalist. Email is vahandavudyan@aol.com. Well, I have to explain exactly the aircraft principles and then explain the aerodynamics for the birds, and then hopefully we can start. Aircraft aerodynamics compared with birds, Geese, by Vahanda Vudyan, physics experimentalist. In these last 30 years, besides conducting many physics experiments, I also watched the plants, birds, animals, and insects behavior. I used to live in Westminster, Colorado for 18 years. Wildlife is so good. I used to sit in a balcony and watch the geese. We're flying, grouping and landing, especially I was interested in laws of aerodynamics. I have always watched air shows all my life. One squadron can be 12 or up to 24 flying in group V shape or delta. Let's say one airplane somehow wants to detach and fly away. There are important laws called roll, yaw, and pitch. I noticed exactly the same thing happened with geese. First they roll to the left or right, then yaw, nose goes to the right or left, and then detach and fly away. Geese fly in V formation compared with airplanes, roll, yaw, and pitch. In these last 30 years, I have always replicated most experiments in physics. I have always been observant and observing animals' behavior. My great inspiration came from nature, animal, plants, and insects. Aircraft principle access. I have to explain about the laws of aerodynamics for airplane first so you can visualize and comprehend. Laws are as follows. 1. Roll. The plane to the right or to the left, ailerons are raised or the wings on the wings and the lower on the others. Yaw is the turning of the plane when the rudder is turned, so one side the airplane moves to the left or right nose and then is pointed in the same direction. The rudder and ailerons are used together to make turns. Third, pitch makes plane descend or climb. The pilot adjusts the elevator on the tail to make plane descend or climb. Vahan's observation in year 2001 in Westminster, Colorado, with flying geese called V formation or delta. There are three lines intersecting at the right angle at the center of the gravity on aircraft. In flight, is free to rotate in three dimensions: roll, yaw, and pitch. And this part is about the bird's aerodynamic. As the birds flaps, a rotating vortex of air rolls off each of its wing tips. These vortices mean that the air immediately behind the bird gets constantly pushed down, and on the air behind it off to the sides gets pushed upward. If another bird flies in either of these upwash zones, it gets free lift. It can be save energy by mooching off the airflow created by its flockmate. Pelicans' V formation energy saves about 11 to 14% of energy. Head to neck create low pressure, which helps to increase the speed and reduce drag. Well, of course, there is another phenomenon, another concept called drafting or aerodynamics, or drafting aerodynamics. I remember when I used to watch, I was so young, I used to watch this cyclist, and then my friend was older than me. He was a good cyclist. He was going always behind it. I asked him, why do you do that? And then he said it's to reduce the drag. I did not understand what the drag meant at that time, and then I learned that is a good technique. Drafting or slip streaming is a technique where two vehicles or the other moving objects are caused to align in a close group, reducing the overall effect of drag due to exploiting the lead object slipstreaming, especially when high speeds are involved. And I have to explain a little bit about the airplane. So today we are talking about aircraft aerodynamics compared with birds, especially geese, by Vahan Davudyan, physics experimentalist, and this is my email, vahandavudyan@aol.com. I used to go to air shows a lot because that was my hobby when I was so young, and then I used to watch them. But something was so puzzling for me. I was so young, and then the first time I went there, I realized they are flying like a V shape. I had no idea, so I had to ask a pilot, and then they explained everything, and then I loved it, and then I fell in love with laws of aerodynamics. See, if this is an airplane, let's say it's in a horizontal, you see right there, that dot over there is the center of the gravity, and all these three lines are intersecting at the right angle where the center of the gravity is. So one of them is roll, you can see it's going all the way, it's a longitudinal, and the other one is yaw, it's vertical, so it goes all the way, and it's like 90 degrees here. And the other one is pitch lateral. But that's amazing. That is all the airplane needs, because they can free to rotate in any direction. I'll give you an example. See, this is one squadron. You can see we have exactly 12 airplanes here. Let's say I'm the pilot here on number 3, and somehow something happened. I have to detach from this V formation. I cannot just fly away. There's certain rules. So first of all, I have to roll, and then I have to roll, and then turn my nose, and then fly away. And here you can see the birds. This is a nice picture. You can see it's exactly the same concept, and then I have to put some airplanes so you can compare to see. They are always in V formation. And this is amazing animal. Well, of course, most of them are, but geese is amazing. In Colorado, I used to watch them all the time. And I remember one time only saw 2 geese, and one was behind. I said, wow, they are extremely intelligent and smart. And I remember when they were landing in Westminster, Colorado, like thousands of them. That was a huge open space. And then when they fly, in a few minutes, they group. I mean, they just form, and then they get this. And sometimes I remember having seen this V formation like a mile. That is amazing how smart this animal is. But of course, you know what? Whoever the lead is, I have no idea. It's not a scientifically proven why she is the lead, but after like 1 hour or half an hour, it depends on altitude and how hot the weather is, they have to change, and then someone else. But it looks like, they are all good pilots. So God forbid, if something happened to a pilot, the other pilot can take over. So they all have the same ability to lead the group all the way. So you can see, I had to, because I'm an experimentalist, always I have to demonstrate everything so you can visualize. So I had to buy this airplane and then mount it myself. Before I do this, I have to explain something. This is amazing invention, and I remember I used this in university. That was 13 years ago, and the professors were amazed with this invention because I have no idea how the pendulum worked on the focused pendulum or the universities or colleges. See, you can see This is fine ball bearing, and it can go 180 degrees, which we don't use 180 degrees at all. But unfortunately, there is a problem. Always when it doesn't matter. My weight was only 150 grams. Mr. Focus in France was 28 kilograms. It had a lot of kinetic energy. So imagine when this goes back and forth, and swinging left and right, what happened? Earth is rotating underneath, so this is getting deflected a little bit, and then I realized that is not good. That is causing a lot of friction. So I came up with this idea. You see, this is amazing idea. You can see this is rotating 360. This can also rotate 360. But see how smooth they are? So I use the same concept here. I show you. See, I am pilot number 3 here, so I just want to detach, and something happened. I had a mechanical problem or something, or I don't feel good. So look, this is the way you do. First you roll like that, and then you yaw. So what happened? The nose goes to the left or right. Well, it depends on, if I'm flying on the right side of the delta shape, it's going to be the other way. So roll, yaw, and pitch. Well, of course, this one is a little bit larger, and then I had to explain this. This is the same thing. You can see this can go 180 degrees this way and also 360 the other way. So of course this is not an airplane, but it's a little bit larger. It's a Southwest. See, if I want to do roll, I go like this, roll, and then yaw and pitch. Well, of course, I have to explain, animals are smarter than humans. Well, of course, airfoil for the birds been millions of years, but we discovered when the Wright brother came, and then it's been 100 years and so and so. But that's amazing how the birds are flying for millions of years, and then we did not notice because our observation was not that good. But anyway, the Wright brothers took care of everything, even though the German scientist knew about that, and he wrote a book. But unfortunately, the poor man died in a crash. And this is the technique for the airplane. Well, I had to exaggerate a little bit. It's more round. You can see here is the fuselage. You can see how round it is. But you can see this part is flat. And this is amazing laws in physics. And then, of course, I have to cut this, and then you can see that's called, see, bird's airflows. You can see this part is round, and the bottom part is flat. And in fact, I have to mention one of the greatest minds in the history of physics. His name was Daniel Bernoulli. He was from Switzerland, and well, of course, it's a lot of formulas, but always I have to simplify things. It says, when the speed of moving fluid increases, pressure in the fluid decreases, and vice versa. I have to clarify something. Air is also fluid. It's despite public perception, the water is not fluid. Yeah, it is fluid, but the air is also fluid. So imagine what happened. Daniel said, air is flowing here much faster, and it is exactly the same. So in other words, this is a little bit longer to travel air, and then here travels much less, and is causing a difference in pressure. That's exactly what we want. Airplane with 100 tons, it goes in the air maybe I checked most of the time 28 seconds. The huge airplanes takes 30 seconds, but 28 seconds is made. So when the airplane goes like this, so what happened is cutting through the air, then air goes under and over, but here it goes faster and is creating difference of pressure and goes up. And you can see this is the airplane in a simple case. Then I have to draw this, and then you can see it's round on top and flat on the So, and then these are the four forces, just you guys know, this is called thrust, this is called lift, this is called gravity and drag. And in fact, you can see the airplane, the important one, the wings are so good, the air goes. Well, of course, we don't want to go in details like, F-14, Tomcat, and F-16 or whatever. Wings is not like this. So the more your wings, because this is like a normal airplane, but the more the wings are closer, they go faster. But for the commercial airplane, we don't need, the V is, it's a flat V. But for the Tomcat or for the fighter jets, it's so they can go much faster. Well, of course, the aircraft aerodynamic compared with the birds, my observations, exactly like Michael Faraday and Tycho Brahe, I took notes with all details. I noticed birds' agility is incredible. They can perform, roll, yaw, and pitch simultaneously and much faster than aircraft. They can even take off when floating on the surface of the water. Well, of course, there are more laws involved, but I don't want to go and then, well, of course, you get an idea what happened. So, this is exactly the same way. Well, of course, this is not for geese. Most birds does that. But I had to watch the smaller birds and the big birds. Well, of course, this is laws of physics. I mean, a small bird can just go like, some birds I've seen, they flap like 6 seconds and then they can glide like 10, 15 seconds. But the geese can't. Geese is huge. It has a lot of mass. But overall, their agility is so good. And I have seen the small birds, they can perform this roll, yaw, and pitch much easier than geese. Well, anyway, the principle is the same. But I don't know why we did not take advantage of the birds that they've been flying so many years. And even I saw when they land, how they landed, and it's amazing. In Westminster, Colorado, like 18 years, I have never seen two birds collide. And unfortunately, sometimes in the air shows we have that these things happen. And then, some airplanes, it's a human error or somehow, mechanical failure or something like that happened. But this is my email. If you have any ideas or anything, you let me know so we can discuss that. Well, of course, like I said, this is just a little bit of everything. It's a whole big picture, but these are the basics, so at least you know how or why I compared the birds with the aircraft. Thank you very much for watching.